Take the myth that guns can't fire in space, a popular belief built on the idea that without oxygen, combustion is impossible. Yet, modern gunpowder contains its own oxidizer, making it perfectly capable of firing even in a vacuum. In fact, without air resistance, a bullet could travel faster, farther, and longer than on Earth. However, there's a twist. Recoil in zero gravity would push the shooter backward, turning every shot into a tiny rocket boost. Then there's the comforting idea that Jupiter acts as Earth's cosmic protector, shielding us from asteroids. While it's true that Jupiter's immense gravity can deflect some space debris, it can also do the opposite, flinging otherwise harmless objects toward the inner solar system, sometimes even in Earth's direction. Rather than a guardian, Jupiter is more like a cosmic troublemaker, constantly stirring the solar system's balance. Movies have also convinced us that the vacuum of space would make a human body explode instantly. The truth is far less dramatic, but no less terrifying. Our skin and tissues can withstand the pressure difference, so you wouldn't burst, though moisture in your body would boil and you'd lose consciousness within seconds due to lack of oxygen. It's a slower, more silent death than Hollywood suggests. Even the phrase zero gravity is misleading. Astronauts in the International Space Station aren't floating because gravity disappears. They're in constant freefall around Earth. Gravity at that altitude is still about 90% of what we feel on the surface. But because both the astronauts and the station are falling together, they experience weightlessness. Gravity never vanishes. It just becomes imperceptible when everything around you falls at the same speed. Comets, too, are victims of misunderstanding. Their tails don't always trail behind them like hair in the wind. In fact, a comet's tail always points away from the sun, no matter which direction it's moving. This happens because solar radiation and solar wind push dust and gas outward, creating two tails, a curved dust tail and a straight ion tail, that shift as the comet orbits. And of course, black holes, the universe's supposed vacuum cleaners that suck everything in. In reality, a black hole's gravitational pull isn't stronger than that of any object with equal mass. If our sun were replaced by a black hole of the same mass, Earth's orbit would remain unchanged, just darker and colder. Black holes only become dangerous if you venture too close, past the event horizon, where gravity is so intense that not even light can escape. Lastly, Pluto's fall from planetary grace wasn't due to its size. The true reason lies in its inability to clear its orbit of other objects, a key requirement to be classified as a planet. It shares its orbital zone with many Kuiper Belt objects, disqualifying it under modern definitions. Ironically, if we applied those same rules to the early Earth or Jupiter, they wouldn't have made the cut either. The more we explore, the clearer it becomes. Space is full of truths that challenge our assumptions. Every myth we debunk reveals something even more fascinating about the cosmos. The next time you gaze at the night sky, remember, reality, not imagination, is often the strangest story of all.